Hey, what's up guys? In this video, we're going to clone a very simple game using Flutter. And if I'm not mistaken, this is probably the very first game to ever be coded up in history, I believe. And that game is of course Pong. Now just before we dive right into it, if you want to check out my full code to this game, then you can go to my website and download it from there. I always add additional features and menus and things like that, and further bug improvements on top of what I'm about to show you in this video. So if that's something that you're interested in, then go to my website, that's linked in the description. But other than that, let's get right into it. Now let's delete everything from here on down, because we're going to create this game completely from scratch. And let's create a stateless widget called my app and return the material app inside. Now let's do the usual things that I usually like to check off, like the debug banner. And for home, we'll call it homepage. Now let's create a new file called homepage.dart just to make our code nice and clean. And make sure to import the material.dart file like usual. And let's create a stateless widget called homepage and return a scaffold. So whoops, we should actually go back to the main.dart and import this homepage. Okay, so if we save this now, we should just have a blank app. And let's close this and we can just create everything in our homepage. So first thing, let's make our background color gray. Maybe a strength of 900, so a bit darker. And with most of my games, I always use a stack because it's nice and handy. We can position a lot of different elements on top of each other. So inside the stack, we're going to create containers and use alignments to position the different elements of the game around the screen. So 0, 0, again, if you're not very familiar with it, 0, 0 is going to be in the middle. It's the X and Y coordinate. And just to start us off, let's see something visual. So let's create a container of height 20. And for the width, let's, instead of specifying a specific width, let's use the media query and divide that by 5. So it just means the available width of the entire screen, but 1/5 of that. Cool, so there it is. Now let's wrap this container in something called clip rect, which is what I like to use. It always makes things look very nice because the borders, like the corners I mean, become really rounded. So you'll see in this one. Yeah, so something like that. Now let's create another file called brick.dart and import the material.dart file like usual, and in this stateless widget we're going to call it my brick. And let's create this white brick in this file. We'll separate it out again just to make it nice and clean. Now a couple of constructors to make. So I want to pass through some information to this brick when I create it. So the X, I want to know the Y coordinate, and I think that'll do for now. We might have to add some features later on, but if I pass through the X and Y, then we can specify those values for the alignment. And again, we can use this to position the elements around the screen. Now let's finish off creating our constructors. So my brick, this.x and this.y. Cool, which means if I come back to my home page, let's create a top brick and a bottom brick. And because we're going to create 2 bricks, that's why we created a separate file called brick.dart, so that we can do something like this. We can just say my brick, specify the X, specify the Y. So for the Y, let's say it's the top brick, right? So -1 is at the top and +1 is at the bottom. So let's say -0.9, so it's near the top. Whereas the bottom brick, let's specify +0.9. So we should be able to see on either ends of the spectrum. And for the X being 0, that's just in the middle. So again, these values are between -1 and 1. So Let's create one more file for the ball. So import material.dart. And for this one, we just want to call it my ball. And the main goal here is to make it into a circle, like a white small circle. So alignment, similar idea, we need an X and Y to pass through. So let's just quickly create that and create the constructor. So in the container, we can specify the circular property in the decoration. So you should be able to find box shape.circle. And in here, we can specify a color. Let's just make it white. And let's create this in our homepage. So my ball. For the X, let's just start off in the middle. So X equals 0 and Y equals to 0 as well. Now let's decorate this up a bit. So I want to have a user-friendly experience. So let's create a cover screen. And basically what I mean by a cover screen is I want to just put some text before the game starts. And I want it to display a string that says tap to play. So in the cover screen, so we're going to return a container, and of course we need this for the alignment to position where on the screen we want this element to be. So we're inviting the user to tap, so we're going to create a gesture detector to wrap around the entire scaffold. And if you look on the on tap, if we tap the screen, then we're going to start a function called start game. Let's also create some variables because we're going to need to know if the game has started. So initially game has started equals to false. Now once the game has started, we need to move the ball. So we're going to create a timer, which you're going to need to import. For the duration, let's do milliseconds is 1. And let's set the state. It looks like I don't have a set state. And that's because we accidentally made this in a stateless widget. So let's copy all this in the inside, so the whole widget. And let's delete this and create a stateful widget. My bad, we accidentally created a stateless widget. So we need a stateful widget because we're going to need to set the state a lot, which just means we want to update values and move things on the screen. Cool, so now we can set state in our timer. And what we want to change is, first of all, the ball, right? So we don't want to make these fixed values. We're going to have to create some variables for these so that we can change them around. A couple doubles to keep track of the X and Y coordinate of the ball. So just to start us off, let's see if this works. So ball plus 0.01. So I'm just incrementing the Y. And remember, -1 is on the top and +1 is on the bottom, which means this bit of code, adding 0.01 should mean we're going down. Now it looks like it's not actually working. First of all, it could be because this cover screen is in the way. Now in our cover screen, let's pass through the boolean of if the game has started or not, because if it hasn't started, then we'll display tap to play. But if it has started, then there's no need to show tap to play anymore. Oh, this is showing a red underline because we're going to need to put a required tag on that. And let's see how this looks. So hopefully when I tap the screen, it's going to go away. Yep, so tap to play is gone. But it looks like the ball is still not moving. It could be acting funny because we didn't specify a height for the ball. So click it, the ball moves down. Okay, good, sweet. So that was the issue. Let's create a direction enum. And to start us off, let's consider two directions. So up and down. And let's keep track of the current direction of our ball. So let's create a variable, let's call it ball direction. And initially we'll say the direction is down. Now I'm going to separate this out into a separate method to keep things clean. So let's call it update direction. And basically in this method, I'm going to check constantly. Every time this is called, we're just checking the Y coordinate of the ball. And if we have hit the end of the bottom edge or the top edge, then we're going to change the direction. Right? And the values are -1 at the top and +1 at the bottom, and these bricks currently are positioned at 0.9s. So just to see if this works, let's say if ball y is greater or equal to 0.9, then let's change the direction to down. So 0.9 is at the bottom, so if we hit the bottom, actually that should be in reverse, but we'll see how we go. Yeah, and the other one should be ball y is smaller than -0.9. Let's create another method called move ball. So the first method, update direction, is going to update the direction, whereas move ball is going to actually move it according to the direction that we updated. So that's the first method there, and the second thing is to actually use the direction to move. And by the way, I think something in the update direction is the other way around. I think the down and up should be reversed, but we'll come back and fix that once we test it. If the ball direction is down, then we can say ball y and add a number. And for now, let's increment by 0.01. We'll see how that looks. And if we're going upwards, then we want to subtract by 0.01. Okay, let's test this out. As I said, I think the update direction, we got it the other way around. Yeah, so it's not working. We need to fix this up. By the way, if you see any lag on the ball, it's because I'm recording at the same time. Like when you just try it on your machine without recording, or if you just have like a really powerful machine, then it's really smooth. Okay, now the next thing to do is I want to move the brick. So I'm going to use some physical keyboard touches to do this. So let's wrap our gesture detector in another widget called raw keyboard listener. And the first property is focus node. It's just focus node. Autofocus is true, and this is the main one, so on key. So the event, which is whatever the user types on their keyboard, if the event, and we're going to go to the is key pressed method, and we're just basically checking if the event is which key was it. So the first one, let's check arrow left, and the other one to check is arrow right. So those are the two movements that we're going to allow for the brick in this game. And if we hit the left arrow, then move left is the method I want to trigger. We actually haven't created these methods yet, but let's do that real quick now. So void move left and void move right. Cool. So this is a way to link up your physical keyboard to these methods. So if you want to make this a mobile only game, then you might not want to do this physical keyboards. You might want to have to do the touchscreen on the device, which should be not too difficult to do that. But yeah, the rest of this code should be the same as the mobile. So let me know if you have any issues with that. But yeah, there should be plenty of resources out there already on that, as well as on my channel as well. But yeah, moving left and moving right. So player X is the X coordinate to control, and let's increment by 0.05 for now. Let's see how that looks. I created the variable for player X, but I didn't put it into my brick. Okay, so yeah, it looks like we can move now a little bit. Oh, I couldn't move right because I didn't actually say move right. Yeah, there we go. Arrow right, I mean. Cool, we can move left and we can move right. I feel like we're moving a little too small of increments. We can say maybe 0.1. Let's double the movement. Now in the direction, let's add left and right as well. So we have up, down, left, right now. So let's just copy the code that we created for the vertical movement, and we checked ball direction. Now we're gonna have to split this into two different variables now. So instead of just considering ball direction, we're going to need to consider ball Y direction and ball X direction. And so ball X direction is going to, if it's left, then we're going to change ball X. And we should say that that's minus for moving left. Second if statement is moving right, and this should be plus. Cool. Whoops. Okay, now, so it's moving the right, like diagonally, but it's moving off the screen. So we're going to have to go to our update direction to have this notion of hitting the wall. So again, let's just comment this code out because we have, our code is growing. So the first thing we're doing here is updating the vertical direction. Let's now update the horizontal direction. So we want to check basically ball X and if it hits the wall. So how do we do that? So if ball X is greater than equal to 1, that means it's hitting the right wall, in which case we want to turn the direction to left. And the second if statement is if ball X is less than or equal to -1, meaning it's touching the left wall. So there we go. So it's basically hitting off the walls now. Now in our update direction, so currently we only checked like to bounce back upwards if we are greater than 0.9, our Y coordinate for the ball. But we also now want to check that it can only bounce off if we're hitting one of the bricks, right? So in which case we need to not only consider the Y coordinate, but also the X coordinate. So we're going to have to use an inequality to connect ball X and player X. So ball X is greater or equal to player X. So player X, remember, is the X coordinate that's on the left side of the brick, like the very left of the brick. So we're going to have to use that first. So player X is greater or equal to ball X. I need a variable called player width because I need to know if the player X is on the left side of the brick, then I need to know the right side of the brick as well. So let's add that into our brick.dart file. So I need to know the final brick width. And the reason why I'm doing all this extra code is because to make it easier to maintain later on, if you for some reason want to change the brick width, then I don't have to at that point change any extra code. It all changes automatically by the use of just some nice maintainable code. So now that we have a player width, let's see how this looks. Okay, looks like that part worked. I just fell off. The ball just fell down. So now that the ball can just go off the screen, let's check if the player is dead. So I'm going to create a separate method out called isPlayerDead, which actually we should call it a boolean since it's going to return a true or false. So bool isPlayerDead. As a default, let's just return false. And what we're going to check for is we're going to check if the ball has gone past, if the ball Y coordinate has gone past 1. So that's basically meaning it's going off the screen. I wrote ball X, but I think that should be ball Y. But yeah, in our timer, if player is dead, then what we want to do is we want to cancel the timer. And we also want to reset a lot of the values. So we're going to create a separate method called reset game because we want to set it up so that all the values are set back to its initial values so that we can start the game again if the user hits play again. So in the reset game, we're going to set the state and say game has started. Let's change it back to false. Ball X and ball Y, let's change it back to the middle. And yeah, the player X we're going to change to negative 0.2. Now, by the way, just to test something out, and just to show you guys an issue that I faced, and I had to use some math to solve it. Right now, we're using the X coordinate as player X, and that's what's keeping track of the brick at the bottom side, right? But the brick on the bottom side is more than one particular x coordinate because it's got a particular width. So if you look at this container that I created real quick, I just made it red with a width of 2 and a height of 20. So just a very skinny line. And I just want to show you how some of these alignments work exactly under the hood, because I had to go digging and find what the actual problem was, because some of the code that I wrote wasn't becoming exact, but now I made it exact. I couldn't see it, so I just placed that container on the very bottom of the stack, and now I can see it. So yeah, you can see that red line at the middle. And the y coordinate, let's change it to 0.9 because that's where the brick is on the bottom. And I just want to show you. So the y coordinate, the x coordinate rather, for the brick is, you can see the red line, how it moves. So both of those elements have the same x coordinate. They're both controlled by player x. The red line and the white brick are both controlled by player x, but you can see how it moves. It moves in proportion to where you are. So that makes it a pain in the butt to control if the ball is where the ball is in comparison to our brick, because our brick, which has a width, the x coordinate is where that red line is. Now I did some math to solve this and find a way to manipulate it so that the red line now looks like where it's exactly on the left hand side. And that's what I really want, because that makes it a lot easier to see if the ball is to the left of this red line or to the right of the red line. So I hope that made sense. I'm happy to explain it further if anyone has any questions, but now we can get rid of that red line, and I am comfortable knowing that the variable x for player x is the left hand side of the brick. Now it looks like the ball is still going through our brick, and that's because the x coordinates here are wrong, I think. The player width, I think, should go on added onto this one, and it should be taken off on that last one. Yeah, this should work out. So we're just checking if the ball is between the left hand side and the right hand side of this brick. Yep, that should be the right one now. Now let's save this. Yeah, it works now. Now is player dead? Yeah, so this was a mistake earlier. So ball X is actually ball Y, because we're checking. Yep, there we go. We're checking if the ball reaches past our brick. Now it looks like the reset game just gets triggered right away if the player dies. So I don't want that to happen right away. So let's put an intermediary step. And first thing is, let's show a dialogue when the user dies. So for the dialogue, I've used this many times as well. So I'm just going to copy this particular part in. And so here it is. This is what I just coded up earlier. So when the user dies, I'm just going to show purple wins and also a button to play again. We should also add, since I introduced a dialogue, when I reset the game, which was when I hit the button for play again, you want to make sure to add this bit of code in. So navigator.pop, this makes it so that the dialog box basically goes away. So if you don't have this code, then your dialog box just continues to stick around. But yeah, so once we die, then purple wins. I guess I didn't really specify who purple is. So let's say the top guy, the top brick is purple. And so let's create some variables for this enemy. We're going to need to control its x coordinate. So in our start game timer, where we are controlling all the movement, we also need to move the enemy now. So let's create a separate method for this. Void move enemy. And let's set the state. Yeah, we can do something sneaky here. For now, I'm going to say enemy x equals to ball x, which what that does is it's going to never miss the ball because it's just following the same x coordinate as where the ball is. So I forgot to specify that the enemy x should be in the my brick, so make sure to do that. And yeah, you can see the top brick, it's never going to miss because it's just going to continue following the ball. Let's create a extra boolean called this is enemy. So if this is the enemy, then let's give it a different color. So I want to give it purple color as we mentioned before. And for the width, it depends on the brick width. So let's just clean this up a bit. So brick width out of 2, and it's out of 2 because the axis from left to right is at -1 to +1, so that's a distance of 2. So in the top brick, we can specify this is enemy to be true, and for the bottom brick, we can say this is enemy to be false. So this is a way to just differentiate the colors. In the reset game, we should also reset the enemy to be back to -0.2, so that's where you started originally. And it looks like we we just continually go off the screen if we keep pressing left, so we should restrict that. So let's just close all these tabs, and yep, in the move left, so we want to put a simple if statement. So this little simple if statement means move left unless moving left means we're off the screen. Same thing for move right, but we want to change all the signs around and make it plus since we're moving to the right. And let's just test this real quick. Yep, it's stuck on the right. Stuck on the left, and check the right. Oh, okay, so the right hand side looks like we're still going because that's because player X, we set it to be the left hand side of the brick, right? So we're going to need to add a player width to that if statement, which we actually called brick width rather. So yeah, the player X is just the left hand side plus the width of the brick itself. The left hand side works, but the right hand side looks like we are not completely touching the right hand side for some reason. And I think that's because we can just get rid of this increment. Yeah, let's check that. Yeah, perfect. Okay, so now that we've fixed that, let's also keep track of the score, which we're going to implement neatly behind the game. So basically, first thing, let's just create it real quick right here. So container, and the alignment just in the middle. And for the child, we're basically going to use some text widgets. Now the first thing I want to place is just a line in the middle to separate the two numbers. Let's create a couple more of these and change the y coordinate to -0.2 and +0.2. And these are going to be the two different scores. So here, let's put a text widget. For now, let's just say it's 0. And let's specify the style. And this one, we're going to have to make it really big. And for the color, let's just make it a dark gray color again. Whoops, it's still aligned. So we should copy this text and get rid of all the other container properties. I think the scores could look a little bigger. Let's change these to 100. Yeah, that looks pretty cool. Now let's copy all this and separate it out into a different file just to make it cleaner as usual. And let's call this scoreboard or score screen. So let's go to our score screen file and let's just fine tune it real quick here. The numbers look really squashed together. I want to change these out to 0.3s and make the width a bit smaller. I think we can make the colors more darker. Now we don't want to show this covering the tap to play, right? We only want to show this when the game has started. So that's why that game has started boolean comes in really handy. Let's create our constructor. So when we return the stack, so let's make it depend on if the game has started. If it started, return the stack. If it hasn't started, return an empty container. Also, another thing to do while we're on this file is the zeros are just fixed text strings that we just used, so we don't want to do that. Let's pass through some variables. So let's keep track of the enemy score as well as the player score. So the enemy score is the one on the top and player score is the one on the bottom. We should say toString because enemy score and player score might not be strings. Okay, cool. And finally, let's come to score screen and just fill this out. The enemy score and player score, we didn't actually create the variables here. So let's do that real quick. So enemy score and player score. And if we come over here, if the player is dead, then let's increment the enemy score. We actually don't need these to be doubles because they're just integers. So let's just do that. And if we're checking for if the player is dead, then we should also check for if the enemy is dead. So let's create the method. is enemy dead. It should be very similar to the player is dead. So let's just copy the code from that. And instead, we want to change the signs around and check if it's smaller than -1, meaning it's touching the top. Cool. And when we show the dialogue, we should also pass through who won, right? So right now it's just saying purple wins no matter what, and all of the colors are in purple. So let's change that up. So in the brick, we have the enemy being purple and the player being white. So let's change that to pink just to mix it up. And so in the show dialog, we want to pass through a parameter. So we want to just pass through basically who won. So many ways we could do this, but let's just say Boolean enemy died. And so if the player died, then that's false. If the enemy died, then that's true. So that's just one way to keep track of this idea. So if the enemy died, then return pink 1. And if the other case is true, then the purple wins. So I'm just gonna go through and change all the colors around, and you can see the score screen at the back. It's it looks kind of nice and discreet at the background, and it's also actually working. So as I keep dying, the score keeps incrementing up. Now, one last thing I'm gonna do just to make the game look nicer is I'm just gonna copy this code in. So the functionality is the same, but I added this avatar glow, which we're going to need to specify in the pubspec YAML. So you can see currently it's got a red underline under the avatar glow. But basically, if the game has started, then we don't want to show this avatar glow. But at the beginning, while the game hasn't started, we want to show this nice fancy looking glow. So we're going to need to specify the avatar glow in our dependencies. So let's do that in our pubspec.yaml. Save it, which hopefully gives us the option to import it. There it is. And so basically what this code does is, you'll see in just a second, but it adds this nice glow to it. And you can specify all of these different properties to whatever you like the color, the end radius, things like that. But yeah, so once I click on it, the game has started. So we're going to show the score screen instead. Cool. So that's a nice little touch that we can add with the help of Flutter. Flutter is really good at making simple things like this look nice. Now I'm just going to leave it at that for this tutorial. So if you're interested in checking out the full code for this game, then you can of course download it from my website. I always make additional improvements and further bug fixes, as well as adding additional features to the game like menus and different things like that. So please check it out if that's something that you're interested in. But other than that, I hope this video was able to teach you some basic ideas about coding as well as game development. So thanks for watching, and I'll catch you guys in the next one.